We're going to go through this question in two different ways. So the first thing to do in both cases is to identify that we have an equilateral triangle here and add these 60s on. And then an intuitive approach is to call the angle that we want to find x. I'm going to go through an alternative way in a minute that avoids that. And call something else x, and you'll see in a minute, because this gets a little bit technical in places. So because JOM is isosceles, then this is also x, meaning that this here is 180 minus 2x. Right, now I want to find the sum of these two angles, and we've got 240 minus 2x. We want to add on this missing angle to get 360. So rather than doing 360 minus, we just see what do we need to add on, and it would be 120 plus 2x. Now, these two triangles are congruent. They're exactly the same because their sides are all equal. So I can take this 120 plus 2x and divide it by 2, giving 60 plus x here and here. Because they are isosceles triangles, this is also 60 plus x, and this is 60 plus x. Now you might be tempted at this point to work out this missing angle. You could do. It's going to be 60 minus 2x because the three of them have to add to 180, and the same down here. But in fact, that's not really going to help. If you try and add up the angles of the quadrilateral to form an equation, you'll just get 360 because we've got 6 lots of 60 in the angles, and we've got a 4x and a minus 4x. It is in fact all about the co-interior angles at this point. We haven't used the fact that the lines are parallel. You've always got to kind of bear that in mind in the question. It's going to be useful somewhere. So these two are parallel, which means this angle and this angle, they are co-interior and they add to 180. So x plus 60 plus 2x plus 60 equals 180. That means 3x plus 120 is 180, so 3x is equal to 60, giving us finally x equals 20 degrees. And that is the angle JMO. Let me talk about a second approach to this question. So again, I'm going to identify the 60-degree angles. Now this time, I'm going to call this x. Although if I do, then this will become 9. I'll get 180 minus x for these two, then I'll divide it by 2 to get 19 minus a half x. So I'm going to modify it so that this is 2x. You can do that, no problem. And then we get 90 minus x and 90 minus x. Now this time, I'm actually going to go straight for the co-interior angles because these must all sum to 180. So I've got 150 minus x at the top, then I'm adding 90 minus x at the bottom plus this missing one, and that must equal 180. This is 240 minus 2x plus question mark is 180. So question mark is going to be 2x minus 60. We could have actually taken that approach up here. I'm not, it's not like this is a completely different approach. I just went for the angles in the center on this one and then used co-interior angles, whereas now I'm using co-interior angles first and then using angles in the center. I happen to call it x here and x here, but you could have applied this approach to this question instead. So, there's more than one way to do it, and that's kind of what I'm trying to illustrate here. So this is going to be 2x minus 60, but because they are congruent, this is also 2x minus 60, and that's all I need, because now I can say that these add up to 360. So 6x minus 60 is equal to 360. Okay, because two of the 60s cancel out. 6x is 420, x is 70. Therefore, 90 minus x, that's what I actually want over here, is equal to 20 degrees.